as revealed by our senses was to dominate and stifle Western philosophy. Even as late as 1600, Johannes Kepler was still struggling to interpret the structure of the cosmos in terms of Pythagorean solids and Platonic perfection. Ironically, it was Kepler who helped re-establish the old Ionian method of testing ideas against observations. But why had science lost its way in the first place? What appeal could these teachings of Pythagoras and Plato have had for their contemporaries? They provided, I believe, an intellectually respectable justification for a corrupt social order. The mercantile tradition, which had led to Ionian science, also led to a slave economy. You could get richer if you owned a lot of slaves. Athens, in the time of Plato and Aristotle, had a vast slave population. All of that brave Athenian talk about democracy applied only to a privileged few. Plato and Aristotle were comfortable in a slave society. They offered justifications for oppression. They served tyrants. They taught the alienation of the body from the mind, a natural enough idea, I suppose, in a slave society. They separated thought from matter. They divorced the earth from the heavens, divisions which were to dominate Western thinking for more than 20 centuries. The Pythagoreans had won. In the recognition by Pythagoras and Plato that the cosmos is knowable, that there is a mathematical underpinning to nature, they greatly advanced the cause of science. But in the suppression of disquieting facts, the sense that science should be kept for a small elite, the distaste for experiment, the embrace of mysticism, the easy acceptance of slave societies, their influence has significantly set back the human endeavor. The books of the Ionian scientists are entirely lost. Their views were suppressed, ridiculed, and forgotten by the Platonists and by the Christians who adopted much of the philosophy of Plato. Finally, after a long mystical sleep in which the tools of scientific inquiry lay moldering, the Ionian approach was rediscovered. The Western world reawakened. Experiment and open inquiry slowly became respectable once again. Forgotten books and fragments were read once more. Leonardo and Copernicus and Columbus were inspired by the Ionian tradition. The Pythagoreans and their successors held the peculiar notion that the earth was tainted, somehow nasty, while the heavens were pristine and divine. So the fundamental idea that the earth is a planet, that we're citizens of the universe, was rejected and forgotten. This idea was first argued by Aristarchus, born here on Samos 3 centuries after Pythagoras. He held that the earth moves around the sun. He correctly located our place in the solar system. For his trouble, he was accused of heresy. From the size of the Earth's shadow on the moon during a lunar eclipse, he deduced that the sun had to be much, much larger than the Earth, and also very far away. From this, he may have argued that it was absurd for so large an object as the sun to be going around so small an object as the Earth. So he put the sun, rather than the Earth, at the center of the solar system, and he had the Earth and the other planets going around the sun. He also had the Earth rotating on its axis once a day. These are ideas that we ordinarily associate with the name Copernicus. But Copernicus seems to have gotten at least some hint of these ideas by reading about Aristarchus. In fact, in the manuscript of Copernicus's book, he referred to Aristarchus, but in the final version, he suppressed the citation. Resistance to Aristarchus, a kind of geocentrism in everyday life, is with us still. We still talk about the sun rising and the sun setting. It's 2,200 years since Aristarchus, and the language still pretends that the Earth does not turn, that the sun is not at the center of the solar system. Aristarchus understood the basic scheme of the solar system, but not its scale. He knew that the planets move in concentric orbits about the sun, and he probably knew their order out to Saturn. But he was much too modest in his estimates of how far apart the planets are. In order to calculate the true scale of the solar system, you need a telescope. It wasn't until the 17th century that astronomers were able to get even a rough estimate of the distance to the sun. And once you knew the distance to the sun, what about the stars? How far away are they? There is a way to measure the distance to the stars, and the Ionians were fully capable of discovering it. Aristarchus had toyed with the daring idea that the stars were distant suns. Now, if a star were as near as the sun, it should appear as big and as bright as the sun. Everyone knows that the farther away an object is, the smaller it seems. This inverse proportionality between apparent size and distance is the basis of perspective in art and photography. So the further away we are from the sun, the smaller and dimmer it appears. How far from the sun would we have to be for it to appear as small and dim as a star? Or equivalently, how small a piece of sun would be as bright as a star? An experiment to answer this question was first performed in 17th century Holland by Christianus Huygens and is very much in the Ionian tradition. Huygens drilled a number of holes in a brass plate and held the plate up to the sun. He asked himself which hole seemed as bright as he remembered the bright star Sirius to have been the previous evening. Well, the hole that matched was effectively 1/28,000th the apparent size of the sun. So Sirius, he reasoned, must be 28,000 times further away than the sun, or about half a light year away. It's hard to remember just how bright a star is hours after you've looked at it, but Huygens remembered very well. In fact, if he had known that Sirius was intrinsically brighter than the sun, he would have gotten the answer exactly right. Sirius is 8.8 light years away from us. Between Aristarchus and Huygens, people had answered that question which had so excited me as a young boy growing up in Brooklyn, the question, what are the stars? And the answer is that the stars are mighty suns light years away in the depths of interstellar space. And around those suns are there other planets? And on those other worlds, are there beings who wonder as we do? Here is a light bulb, which is supposed to represent a nearby star. And next to it, and very hard to see because of the bright light, is a planet. Now we'll need a volunteer who would like to come up with these. Ordinarily, you would have a hard time seeing the planet because it's so close that the star washes out the planet. But if we were able to put something in front of the star to make an artificial eclipse, then we might be able to see the planet. So I'm going to stand over here. Imagine that I'm a telescope somewhere near the Earth. And Tab, if you'd slowly move the disk across,
Good. A little faster would be nice. Good. Now you're just beginning